We are going to be learning two types of application problems that both use lines. So the line equation is still something you're going to be doing. The only difference is it's in the context of a story problem. So I have two basic problem types. The front side of the notes page is the first type. And this type of a story problem has a starting value or a base value plus a rate. And so that's kind of how the format goes. So let's read one of these examples. A city parking garage charges a flat rate of $3 for parking 2 hours and 50 cents per hour for each additional hour. Write a linear model in terms of additional hours and total charge. What is the total charge for parking 12 hours? So the typical format is you're going to write a linear model, which will be something in the form y equals mx plus b. And then the second part, you're going to actually use your equation to calculate a value. So there really is two parts to this. Okay, so they've told you what they want in the equation. They want it in terms of additional hours and total charge. So let's call that our x and our y. So x is going to be the number of hours after 2 hours, because the flat fee covers you up to 2 hours. And then our y is going to be our total charge, how much it's going to cost, and obviously the units are dollars. So the basic pattern of this is you have a flat fee plus a rate. So your pattern is you have a total equals some kind of a flat fee that you pay up front, plus you have some kind of a rate fee, and in this case, multiplied by time. So that's your basic format. If they ask you to write your equation in words, that's what we just did. Those are the words. Now we're going to fill in our letters. So our total charge is y equals, and then reading it again, it says it charges a flat rate of $3. So our flat rate is $3 plus 50 cents per hour for each additional hour. So $0.50, because you got to keep dollars in dollars, times the number of hours over 2 hours, which is x. You say, well, Ms. Wright, this doesn't exactly look like a line equation. That's because we just got to put the x second. So your equation is y equals 0.5x plus 3. Now it looks like y equals mx plus b. Put a box around it. That is your equation. You always, always, always have to define x and y. This part is required. You cannot do the problem without it. And when we grade, I'm going to be giving you points for defining x and y. So really important. All right, let's do the second part of the question. What is the total charge for 12 hours? Okay, so we want to know the time. If it's 12 hours, how much we're going to get charged. Now remember though, we only get charged for the hours past the first 2. So 12 minus 2 means we're only going to do 10 hours at the 50-cent rate, because the first 2 are included. Okay, so let's sub that into our equation. Y equals 0.5 times 10 hours plus 3. And then we're going to simplify. So 0.5 times 10 is 5. 5 plus 3 is 8. Y equals 8, but we got to put it in terms of the question. So it's going to be $8. And you put the dollars back in when you actually state your answer. So that is a starting rate plus a rate question. Let's do one more of these. Example 2. 6 2-foot-tall pine trees were planted along the school's during the school's observation of Earth Awareness Week in 1990. The trees have grown at an average rate of 3/4 of a foot per year, which is kind of slow. Write a linear model that gives the height of the trees in terms of the number of years since they were planted. How tall are the trees in 2018? All right, so they want it in terms of the number of years since they were planted. So our X is going to be the number of years since 1990, because that's when they were planted. And they want the height of the tree. So Y is going to be the total height of the tree, and that's going to be in feet. Got to put the units in there. All right, so let's match our pattern. The tree started out 2 feet tall, and then they grew from there. So our total equals the starting height of the trees. So that's your first one, starting height of the trees, plus their growth rate times the number of years that they grow. All right, so let's fill in what we know. The total is Y. So Y equals, they start 2 feet tall, so 2 feet starting height, plus their growth rate is 3/4 of a foot. So 3/4 of a foot times X number of years, which is the number of years since 1990. Okay, so putting it in the right order, our equation is Y equals 3/4 X plus 2. That is our equation. So we have our equation, we've defined our variables, now we're going to use it. So the question is, how tall were the trees in 2018? Okay, so 2018 from 1990 would be 28 years of growth since 1990. So that's what I'm going to substitute in, is X equals 28. So let's do it. Y equals 3/4 times 28 over 1 plus 2. And 28 is 4 times 7. So Y equals 3 times 7 plus 2 is 21 plus 2, which is 23. So our answer is that our tree will be 23 feet tall. You can identify this pattern because it always, always, always has a starting amount, something that you start with, and then it's got a rate. All right, flip the page. It's going to go to type number 2. All right, so this is our second one, second problem type. This type of problem, most people actually like better than the other one because you just find 2 data points from 2 categories. So you're going to make 2 points, basically. All right, so let's read an example. 3 yards of concrete from Jiffy Build cost $35, and 5 yards of concrete cost $53. Write a linear model that gives the total cost in terms of the number of yards of concrete purchased. Based on these values, how much would 4 yards of concrete cost, assuming taxes included? And then this third part, if another contractor's bill was approximately $42, how many yards of concrete did he most likely purchase? So how you know this fits the pattern is that you have 3 yards of concrete goes with a $35 cost, and 5 yards of concrete goes with a $53 cost. So there's your 2 pairs of information. And they want it in terms of the number of yards. Okay, so come over here. X is going to be the number of yards of concrete. And they want the total cost. So Y is going to be the total cost in dollars. So to start this problem, what you want to do is put your 2 pairs of informations together. So here we go. I have 3 yards of concrete for my X, and that goes with $35. And then we have 5 yards of concrete that goes with $53. So my 2 points are 3, 35 and 5, 53. So here's where we were on last night's assignment. We're going to take the 2 points and we're going to write the equation of the line. So here we go. Slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Designate your points, x1, y1, x2, y2, and put them into the slope formula. So 53 minus 35 over 5 minus 3 is 18 over 2, which is 9. That is our slope. And now we're going to pick a temporary point. You can pick either one. I'm just going to pick the lower one, 3 and 35. That's your temporary point for x and y. And we're going to use y equals mx plus b and solve for the b value. Okay, so let's fill those in. My temporary y is 35 equals my slope, which is 9, times my temporary x, which is 3, plus b. And there is your equation to solve for b. And I already know you know how to solve that. So I'm just going to put a dot, dot, dot. 8 equals b. So your equation ends up being y equals 9x plus 8. So we took the 2 points and we wrote the equation of the line. Yes? No. Okay, the next question. How much would 4 yards of concrete cost? Yards of concrete is your x. So we're going to do x equals 4 for yards of concrete. We're going to substitute it into our equation. So y equals 9 times 4 plus 8, which is 36 plus 8, or 44. So it's going to be $44. All right, the last part says, if another contractor's bill was $42, how many yards of concrete did he most likely purchase? So remember, money is your y. So if his bill was $42, that would mean y equals $42. So you're going to substitute that into the equation. You get 42 equals 9x plus 8. And then you solve it for x. And I'm just going to put a little dot, dot, dot. I know you know how to solve for x. So 3.8 yards of concrete most likely is what he purchased. So when you're answering the question, you got to make sure is what the information they're giving you, is it the x or the y? And that's the one that you replace. Okay, so to recap, 2 matching pairs of information, make them into points, write the equation of the line, use your line. Let's do one last one here. Jana purchases 7 yards of fabric for $16.50, then has to return to the same store to buy 3 more yards of the same fabric for $7.45. Now, right away, you should go, hey, I have 2 pairs of information. I have 7 yards and $16.50, and then I have 3 more yards and $7.45. There's my 2 pairs of information, and that's how you know this is a type 2 problem. Write a linear model that gives the cost of the fabric per year purchased. Okay, so my X is going to be the number of yards of fabric, because that's how we determine the cost. And the Y is going to be the cost of those yards in dollars. All right, so let's take the information and write our points. I have 7 yards for $16.50. And then I have 3 yards for $7.45. So taking the units off, it's 7, 16.5 for the first one, 3, 7.45 for the second one. All right, so what we're going to do is write a linear model. So first we got to do slope. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Designate your points, x1, y1, x2, y2, and sub them in. So 7.45 minus 16.5 over 3 minus 7. And I would totally be using calculators for this stuff. And again, just put a dot, dot, dot. Ends up being 2.26 for my slope. All right, we've got our slope. Now we're going to pick a temporary point. I'm just going to pick the first one, 7, 16.5. That's going to be our temporary x and y. And we're going to use y equals mx plus b. Fill the temporary point in, fill the slope in, and find b. So here goes. My temporary y, 16.5, equals my slope, which is 2.26, times my x, which is 7, plus b. There is my equation to find my b value. And again, you solve for b, you get 0.68 equals b. So using that and the slope, my equation is y equals 2.26x plus 0.68. So we have our slope, we've defined our variables, we have our equation. Now we're ready to answer the question. The question is, how much would 5 yards of fabric cost? Okay, yards of fabric is x. So x equals 5, and we're going to fill it into our equation. Y equals 2.26 times 5 plus 0.68. And simplify, you end up with $11.98. So again, the process for a type 2, find 2 pairs of information, make them into points. They tell you what is x and what is y. 9 times out of 10, your total cost is y. Like it's almost always y if it's a total cost. Find the slope, pick a temporary point, write your equation. Use your equation to answer a question. And that's it. Are there any questions?